So we have in the room right now, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
You have one crash. We decided the last minute to come.
Ah, no problem, dude. So we got 10 in here, and we don't start till usually about 6. I anticipated we were going to have some connectivity or functional issues, but it looks like we're
See my face.
going pretty good.
There you go.
Is it white, really white, like it was?
Okay, it works.
Yeah.
Is it really white?
Hey guys, I'm gonna test sharing my screen just to make sure you can see it okay.
Yeah, go ahead.
Super.
Oh. Yeah, I see it nicely.
You see all that text well?
Yeah, we just gotta close some windows and we'll be good.
Pretty good.
That's sweet.
And then is this live too?
Yes, I'm broadcasting now.
Okay.
Text well?
Yeah, we just gotta close some windows and we'll be good.
Pretty good.
What the heck?
And then is this live too?
Yes, I'm broadcasting now.
Echo.
YouTube video?
And then is this live too?
Yes, I'm broadcasting now. I think you have the YouTube video sorted. I think that's you. YouTube video? Oh my gosh. I'm reading. YouTube video sorted. I think that's you. Oh my gosh. I'm reading. YouTube video sorted. I think that's you. All right. Max, can you hear us?
I can hear you, yes.
Oh, cool. You close the tab.
For a second.
Whew. All right. Max, can you hear us? What is going on?
Yes.
Oh, cool. I think my window open.
Do you have another window?
I don't. Max, can you hear us? Oh. What is going on?
Yes.
Oh no, it's the camera. It's picking up the TV. Window open.
Do you have another window?
I don't. All right, Matt. We're gonna have to mute ourselves here. What is going on?
Yes.
Oh no.
Yeah, it's probably a good call with you guys muting yourselves. Let me see if I can just pull up a chat here if you want to chat with me while I'm doing this. Yeah, it's probably a good call with you guys muting yourselves. Let me see if I can just pull up a chat here if you want to chat with me while I'm doing this. Yeah, it's probably a good call with you guys muting yourselves. Hey guys, can you hear me? Yeah, that was totally my bad. I did have the YouTube window open. Sorry about that. You guys want to try bringing your audio back?
Okay, it's back. Let's see how this works.
Okay. Apologies.
No worries, no worries. It happens.
You gave us all a good laugh for the new year, Matt. It's all good, dude. Man, I cannot seem to get this silly thing to work.
Okay, yeah, everything sounds much better.
How are you?
Good, yourself?
Good.
Hey, what's up, John? Have a seat.
Do you want us to turn you up, turn you down? Do we sound too loud, sir?
Awesome.
Yeah.
Sure.
Matt?
I'll take one of those, huh?
Yeah.
You guys sound fine to me.
Okay, go.
I don't know why the white balance is crazy, but you can see us, right?
Well, everybody's, wow, on time. And we're ahead of schedule because we got all our technical issues figured out.
Look at that.
Amazing.
Okay.
We'll give it a little bit. We'll give it till another 10 minutes. Maybe we'll start about 15 minutes early. If you're okay with that, Matt, are you okay with that?
Another 10 minutes, yeah?
Yeah, we'll give it another 10 minutes.
Good.
See how it shows up.
Okay. I'll just go ahead and mute myself until then.
Okay, sounds good, dude.
Sweet.
For if anybody has not been here before, when you walk out the door, the restroom's that way and around the corner, right?
Yes.
Because this door will be locked later tonight, right? It was last time we were here.
Mm-hmm. Yeah, so if you go out, well,
You can push the button right next to the door. It says push to exit, little green button.
Yes.
Just push it and then you're good to go.
Either, so if you go out that way, can you, when the door's locked, will we be, you have to go around or?
after 6.
Good to go.
Yeah. Because last time you guys propped that door open.
Okay, we'll do that
Yeah,
again.
I'll do that again.
Okay, so
Right,
then,
locks out.
just so that you don't get confused, go out this door down here at the end of the hallway, take a left, and then go around through that area over there, and then take another left, and it'll be immediately on your left with an
Gotta
entrance.
do that after 6.
And I think the ladies is real close to there.
Yeah, it's right next. They're right next to each other.
I'll go pop it right now.
Yeah,
That'll be it.
until 6 we're good to stay open.
Yeah, because you guys propped the door open last go around.
That's right, okay. I forgot we have these fancy locks that locks everybody in and out at 6 o'clock.
Somebody else need connectivity? We'll give this a try and see if we can get it to work. You gotta follow the instructions in here, they hit their network. If it's, I tried it. You'll have to use one of those IDs. Wow, how many we got here? I guess I could go ahead and go around the room and see who we have and I can check people in. Since I'm so good about taking roll call, I usually hit all of them. Okay, I know you're here, Tim. Check it in, I don't know how to do it.
Hello.
Hey. Check it in, I don't know how to do it.
Sorry, that's my fault this time.
I did.
That's okay.
Okay.
I'm not gonna worry about it. You have a sheet of paper?
You can go grab one.
What's that? Yeah. Well. Okay. Let's see, is everybody here? Yes. Yes, everybody's here. Okay, well, anyway, welcome to January's Arizona PowerShell User Group. I'm Tom. Usually one puts it together, and I have several folks here that help me out, namely Oliver and Abraham, and it's my wife puts up with me. Our speaker for this week is Matt Graeber. He's pretty well-known security and forensics guy that works up in Washington. very well known and respected in the community. He's done modules such as PowerSploit and some other modules you may or may not have heard of. And he's here tonight to show us one of his newest modules that he wrote for doing some discovery of machines that are on your network that are running WMI that may or may not be running PowerShell. And he'll start around about 5 minutes. So with that, what I'd like to do is turn over the floor to the folks that were kind enough to sponsor both the venue and the food. As they always do, we appreciate it greatly that you guys were kind enough to sponsor us every month. We appreciate it a lot. So hopefully it's been good for you. It's been great for us.
Yeah, definitely. Well, thank you guys for coming. Welcome. Happy New Year. My name is Maria. This is Nick. A lot of familiar faces, and some new, I think. Tek Systems, we're IT staffing and services company. So we work with 90% of the Fortune 500 companies here in Phoenix. We have relationships with Wells Fargo, American Airlines, American Express, APS. The list goes on and on. Nick and I are both systems-focused recruiters. So we focus in the Windows space. We're here to help with any career needs that you need, helping you with even just resume help or looking into the future. So both of our cards are here. If you need anything, call us, email us. We're always here.
And once again, thank you very much for sponsoring with the food and the event and all that business. So really
if you guys get sick of pizza, let us know. We'll change it up.
They were doing it, for those of you that were with us at the Microsoft store, they were doing Pita Jungle as well for a while.
We got some complaints, so we had to switch it up a little bit.
Time to switch it up.
Well, the bags are nice. We
Right?
ended up using those bags.
Pita Jungle bags, yeah.
Oh, and those tongs.
Yeah, those were great.
Those were nice too.
So Pita Jungle next time, or?
Sure.
Well, I think we'll get out of you guys' hair. Let you guys.
Well, you can stay and listen and learn stuff if you want to.
We'll lower my head, you know.
Well, thank you.
Yeah, of course.
I wish we could turn down the white balance on that.
And it's crazy. That's okay. We'll see mostly his display anyway.
Yeah, but everybody in the community will see this as well, but that's okay.
It's not a PowerShell command? Set white balance?
No, he's actually using a Chromebook.
Yeah, I was having trouble with my Windows. All right, Max, I think you're up.
All right, can you hear me?
We can hear
Yeah,
you.
we can hear you.
All right, let me pull up my video. Be able to see me now, yeah?
Good to see you.
Cool. Okay. So thanks a lot for having me, guys. Again, my name is Matt Graeber. I'm the manager of our research and development group within the Varus Group Adaptive Threat Division. So within our team, we do a lot of offensive and defensive work. So me being in the R&D section, me and my team, we both help develop capabilities for both our offensive guys and defensive guys, and also just work on longer term projects. So lately, something that I've been very interested in, and some of my colleagues like Casey Smith, who I have here, have really taken an interest in Device Guard, which is a new application whitelisting technology from Microsoft that's available in Server 2016 and Windows 10. So there's a large PowerShell component to that. Casey and I plan on giving a lot of talks this year about that, but that's not why I'm here today. Today I want to talk a little bit about WMI, SIM, and a relatively recent module that I developed called SIM Sweep, which is designed to pull back security-related information, or really any information that a defender or even an administrator might want to pull back remotely, regardless of the presence of PowerShell or PowerShell remoting. So without further ado, before I get into the demos for SIM Sweep, I just wanted to give some background on the SIM commandlets. So the SIM commandlets were introduced in PowerShell version 3 as a means to replace the WMI commandlets. So what are the benefits over the SIM commandlets over the WMI commandlets? For starters, the SIM commandlets are more like open standards driven. WMI has always been like Microsoft's very particular implementation of the OMI specification. SIM is more open standards compliant. And you'll notice if you look at both commandlets side by side, there's pretty much one-to-one parity between the two, with some noticeable differences, and I'll get into those briefly. But first, one of the unique advantages over the SIM commandlets, of the SIM commandlets over the WMI ones, is that by default they support WSMan. So when you hear WSMan, basically just think PowerShell remoting. So if you have PowerShell remoting enabled in your environment, then the SIM commandlets are going to work seamlessly over that remoting protocol, which is WSMan under the hood. Another good thing about that is, okay, so you have WSMan, but then if you need to fall back to the legacy protocol, which the WMI commandlets use, DCOM, you can do that as well by specifying the you call the new sim session option commandlet and specify a protocol of DCOM. So it allows you to use your existing infrastructure of PowerShell remoting if you want to, but if that's not an option, then you can always fall back to DCOM. Now the downside of the WMI commandlets is that it only operates over DCOM. And DCOM is not a particularly firewall friendly protocol. There's a bunch of like high ports negotiated dynamically, whereas like with WSMan, you're dealing with just port 5985 or 5986 if you're dealing with SSL. Another really nice thing about the SIM commandlets is that if you build functionality around them, then at a minimum, all your function really needs is a SIM session parameter. So the WMI commandlets have a ton of parameters that you would probably want to like proxy in whatever functions that you're creating like WMI wrapper functions for. You don't have to do that with SIM commandlets. Basically, all you do is you call new SIM session once, save that to a variable, and then that's what you pass to the SIM session parameter of any SIM commandlet. So it's really nice. It makes developing tools around SIM really easy, in my opinion. Another benefit of the SIM commandlets is that, well, the WMI commandlets just don't exist anymore in PowerShell core. So if any of you have been working with, actually, I think it applies to open source PowerShell as well. If any of you have been working with open source PowerShell or PowerShell core on Nano server, then you may have noticed that the WMI commandlets just don't exist anymore. In my opinion, that's completely fine because, as I already stated, the SIM commandlets are backwards compatible with the legacy DCOM protocol if you have to use that. Now, I'm going to go ahead and start sharing my screen here. And I will mute my video. So let me share my PowerShell window here. Can everyone see that?
Yeah, we can see that, sir.
Okay, great. So one of the cool things about the SIM commandlets is that if you're not really familiar with them, then you may not have realized that you're actually using SIM under the hood very frequently. There's a tremendous amount of commandlets, get net IP. So here, I just did get net IP address. So it turns out that this is a SIM-based commandlet. Now, how do I know that? There's a few ways. So you do a help get net IP address, and you'll notice that there's a supported -sim session parameter. So that's a pretty dead giveaway. I could do get command get net IP address. And you'll see that the implementation here is basically a proxy function around CDXML. So CDXML it's an XML specification that allows you to automatically generate PowerShell functions around WMI classes. There's been a few talks on the subject. Actually, I think it's just Richard Sidaway who's given talks on the subject. There really isn't any like public tooling available to develop these CDXML commandlets. But if you are familiar with the XML schema for this, it's actually a really handy way to just auto-generate functions if you're just wanting to build some simple, intuitive automation around WMI queries. So Microsoft makes very heavy use of this in the form of a ton of these CDXML modules. So you can actually just call import-module on a CDXML XML file, and it will happily load that up for you, and then you'll have a bunch of functions with the supported sim session parameter. Now, I'm not going to get into the details of how to build your own CDXML. It certainly has its benefits, but I generally don't use it. There's a bunch of like automation that I needed beyond what the CDXML schema would provide me. I'll cover those shortly. Now, just to get an idea of some of the commandlets that support the sim session parameters, one of the really handy arguments that you could pass to get command is parameter name. So I want all commandlets that, or functions that expose the sim session parameter. And we'll see a bunch here. So obviously, sim sweep, which is what I'll be talking about, net TCP/IP. Now this is only showing all commandlets that support the sim session parameter that have, so modules that have actually been imported. I would have to import all the modules available to see all the modules that contain the sim session parameter. Okay, so let me now show you some WMI. All right. So a while ago, what I had been kind of accustomed to, and it was a total pain, was like I wanted to be able to pull, for example, file or registry information back remotely from a system. So is anyone here kind of familiar with like WMI queries and what they look like? Or has anyone ever done any like sim data file queries?
Yes.
No.
Yes? Okay. So at least one of you probably know the pain involved in developing a sim data file query. For those who aren't familiar, let me show you the pain. Okay, so here I'm getting a sim data file instance for the object representing the file kernel 32. Now, it turns out this query is really difficult to work with. So what I have to do here is fill out this query manually. So you can't do it such that, so like a WMI query would look like select star from sim data file where file name or file path equals C Windows System 32 kernel 32.dll. Unfortunately, you can't do that query. You have to break it out like this. So this here is the equivalent of saying select star from sim data file where drive equals C : path equals Windows / System 32, file name equals kernel 32, and extension equals DLL. That's a serious pain. So if I'm wanting to scan a bunch of files or pull back file information remotely at scale, well, it's going to be a massive pain, right? So this was sort of the initial inspiration behind developing SimSweep, was to abstract away a lot of these queries so that the user doesn't have to build any WMI queries. You don't even have to be familiar with WMI queries at all to be able to use SimSweep. Okay? Now, here's another pain point for me. When I'm having to work with a registry, the registry is kind of weird with WMI because there's no instance class. So like I can't do like a select star from Win32 registry where subkey equals HKLM software current version Microsoft Windows run, right? Like there's no way for me to represent that. What you have to do is use the std_regprov class and invoke the various methods in it. But here's what that would look like using the sim commandlets. So I'm invoking a sim method. The registry class that's implemented across all versions of Windows is std_regprov in the root/default namespace. The method name that I want to execute is called enumValues. So for a given registry key, I want this to tell me what all of the registry values within that key are. And now I have to give it some arguments. So hdef key, this is the numeric representation of, in this case, hklm. And then I give it the full key path. All right, so does anyone want to tell me the significance of this registry key?
Startup.
Yep.
Startup.
Yep. Yeah, so in security parlance, we would call this a persistence item. So as an attacker, this would potentially be an enticing place to get your malicious payload to execute at startup every time. The defender, of course, I'm gonna want to be able to query this and see if there's any difference or any additions or removals as I sweep my enterprise for this security-related information. So I'll hit enter here, and it returns a couple things. So it gives me the names of each value within that registry key, and it gives me some numeric type values. So you probably wouldn't know what these are without looking them up. So you'd have to go to MSDN, look up what these values are, and it turns out it corresponds to type 2 is a reg expand SZ value. So that it could have, so I'm trying to refresh my memory. I believe that that is a string value in the registry that can have percents to like in order to like tell Windows to automatically expand environment variables. Just a reg SZ, just a straight up string. So I mean, this is kind of useful now, but really what I'm after is both the value name and the actual value contained for, say, Windows Defender or Logitech Download Assistant. The name itself, I don't really care about. What I care about is the actual data in the value. So let me demonstrate some more here that you would have to deal with. So if I wanted to, now that I know what the type numeric values represent, then I call the corresponding std_regprov method. So in the case of Windows Defender, that's the expanded string value. So I have to call get expanded string value with this path, with this hive, hklm, and the Windows Defender value name. Okay, so now I have the value. Okay, so this is pretty useful information to me. But, so, I mean, this takes a lot of work to form these queries manually. And also, the data is not really associated with the key or the value name, right? So I don't get the key in this output. I don't get the value data in this output. I don't get the value name in this output, nor do I get the value key. So I'd like to correlate all that together, and preferably without creating all these like manual queries or sim method invocations. So let me show you the first demo here of get sim or of SimSuite. I'm going to do a get command module SimSuite to show you what is currently available in there. And if you were to pull this up on GitHub, you would see that the module is broken out into different folders. There's a core folder, which comprises the core functionality of SimSuite, which is basically the ability to pull back file information, registry information, event log information, service information, and one or two other things that are escaping me. But let me show you the file stuff first. So I wrote get CS directory listing. Now, if I want to get the same information that I had before for kernel 32, I just give the path, the file name, and that's the same exact output as before, only I didn't have to, supply that extremely complex WMI query. Now, let's say I just wanted a directory listing in System32. I can do that as well. All right, so it's going through and listing out all of the directories and files contained within System32. Now, these are, the reason the output looked a little different, I don't know if you caught that as it was scrolling through. Let me show you here. Yeah, right here. So these are actually, the directory listing is I believe it's a Win32 directory class instance. And then the files are SIM data file instances. And it turns out that they actually derive from the same parent class. The PowerShell team just decided to have the default output be different for a directory versus a file. So that's the discrepancy here. But all of the fields are pretty much identical in both of these classes because they implement the properties from the same parent class. Now, another cool thing that I wanted to do was, let's start with C. I can also recurse. That's kind of cool. And so all this is doing is it's abstracting away all these complex WMI queries so that the user doesn't have to worry about that at all and waste time forming those queries.
For this particular instance, when you're getting the directory list, and what are you doing that's different than what you do from like get child item?
Sure. So that's a great question. Get child item is not using WMI under the hood. So get child item is going to use all of the .NET methods under the hood to do that. So the benefit of using get CS directory listing is that, for example, I could establish a SIM session with a Windows 10 system, with a Server 2016 system, and a Windows XP system, establish 3 SIM sessions, and then get directory listings on all of them remotely, all without needing PowerShell or PowerShell remoting on any of those systems.
Okay, thank you.
Yeah, sure. Yeah, so I mean, get child item is great. Like you would be able to do that remotely if every system that you were going up against had PowerShell remoting enabled. I mean, that's definitely an ideal scenario. One of the reasons, another one of the motivations behind developing SIM Sweep was that we were at a customer site and they had some pretty strict change control procedures in there, and we had to get in there really quick and pull back some like time-sensitive security information. And what this WMI or SIM-based solution allowed us to do is basically we just had them give us credentials to pull back all this information remotely. The WMI service is listening on every single system, like from NT4, Windows XP on up. The service is really listening, so we didn't have to change anything in the system. We just were issued credentials, and then we were up and running with pulling all this back. They hadn't deployed PowerShell remoting enterprise-wide, but they needed the visibility enterprise-wide. So this solution was able to deliver that for them.
Okay, thanks for the explanation, Matt.
Sure. All right, so I also showed you the pain involved with dealing with a registry. So get CS registry key. Now we have some nice tab completion here. So I want HKLM. So the sub key is software Microsoft current version run. Okay, so the reason that didn't return any output is because get CS registry key will list out subkeys. So it's like doing a directory listing on the keys. If I want to list out the values within a key, I would just do get CS registry value. And here we have all the contextual information that we need for those registry values. We have the hive, the subkey, the value name, the data type, and the value itself. And what's cool about this is that depending on what the data type is, so for example, if it was a reg_binary, value content would just be a byte array. So getCS registry value will interpret the data based on the registry value type. Okay, so now that I had like a lot of the core functionality implemented in SimSuite, I wanted to build some automation around that. So one thing that I started to do, and I have almost all of the features available in it, is getCS registry auto start. So this is auto runs. If you're familiar with auto runs, .exe and sysinternals, this is the pure WMI equivalent of that. So let me show you the help here. And if you're familiar with auto runs, you'll notice that the switches in the function correspond to each tab in auto runs. So I haven't implemented all the tabs just yet, but I implemented the ones that were most important to me and our customers at the time. The more common one that you may be interested in would be the logon tab. So here are all the logon items, which is basically almost a one-to-one correspondence to what you would see in autoruns.exe in WMI. And again, cool benefit of using WMI is that PowerShell remoting is not a requirement here. And I'm not pushing or executing any code on the target system. I'm just pulling back information from WMI. So this made our customer really happy because we didn't have to push software agent or execute any script code on the target. Just doing pure WMI queries, or in some cases invoking some WMI methods, as is the case with the registry. But in the end, we're just pulling back information. We're not affecting the system state of the systems that we're going up against. So are there any questions thus far before I continue to dig in here?
Do you have any snapshot capability where you could take a snapshot of the registry and the file system for like comparison with WMI?
Yeah, I don't have that functionality built in. All I can do is just, do like the equivalent of get child item using WMI. So whether it's the file system or the registry, I more or less have the equivalent of just WMI equivalents of, say, get child item, or in the case of like services, instead of get service, I'd get CS service. Here I get all the service information. And the reason, again, you're seeing different output displayed here is because there's two different types of service objects in WMI that inherit from the same parent class. One is like your traditional service that is either an executable or like an SVC host process. The other is a driver. WMI treats both of those the same, and so I return all of those unless you want to just specify drivers, then I could just filter out the drivers. So again, the point here is to be able to pull back as much information as the WMI repository will allow without affecting system state or executing any kind of code on your target systems. Now, when I was designing SimSweep, there were some pretty unique design considerations that I had in mind. For example, one common mistake that is kind of a pet peeve of mine that I see in both non-malicious and malicious software is the assumption that the system drive is contained within the C drive. Well, you don't have to have it. It doesn't have to be C Windows System 32. You can move that to D:system 32 if you wanted to. So I never wanted to assume with certain functions that Windows System 32 would be contained in the C drive. So if you're doing everything over WMI, then how might you go about determining what the system drive is? Any ideas?
Some built-in class, something, I've seen it though.
Yep. So get.
Like, can't you query the volume drive or something? I don't know.
You can do that, yeah. The best one that I found was Win32 operating system. Right here, in the system directory property. So I have some commandlets, or some SimSweep functions that rely on this. So one design consideration that you should always have in mind when developing sim-based commandlets that are going to operate at scale is how much information you pull back and how much filtering you do. So, for example, if I had, if I was writing some function that needed to pull back file information from System 32, and I didn't want to assume that it was C Windows System 32, well, I would start by doing something like this. Property, system directory, class name, Win32, operating system. So you'll see the difference here in that the only property that's actually populated is system directory. That's the only information I need. So that's the only information that I should request from the OS. So when you're doing these sweeps or performing these queries at scale across thousands of systems, you'll need to be mindful of bandwidth and latency. So only ever pull back the information that you absolutely need. And you saw before I provided a filter option. So you could use this to further constrain stuff. So here, let me show you an example. Get sim instance. Let's do Win32 process filter name equals notepad.exe. Okay, so if I was doing something and like all I wanted was to see running instances of notepad.exe, then you should use -filter, which is the equivalent of this. -query, select star from Win32 process for name equals notepad. So this is just -filter is just shorthand for filling out this full query. And now let me show you some shorthand here. If I just wanted to get the process ID of all running Notepad processes, then I'll do select process ID, enter all I get is the process ID. So let me show you the shorthand for all of that. So our class name is Win32 process. And then the equivalent of select process ID would be dash property process ID, where name equals notepad in the filter. Okay. So this returns the same information as before, just you have these convenient helper parameters so that you don't have to be filling out these queries by hand or using like string substitution to fill in these parameters. Okay. All right. So another interesting design consideration was obviously I want to pull back information from the registry, but how would the concept of HKCU apply? Well, if I'm pulling back security-related information, then like, how would you define HKCU, right? The current user. You would probably want to pull back registry-related information for all users, right? So to address that, what I had to do was resolve what user-specific hides were in the registry in HKU, all using WMI in the process. So what's that look like? You may have seen this before. This is some pretty rough looking output here, but in the root of HKey users, you may have seen these SIDS before. So there's a bunch of subkeys that are SIDS that correspond to the local users on that system. So when pulling back security-related information, if there's a relevant user-specific registry key or value that I'm interested in targeting, then I have to do it for all the users defined within HKey users. Because in WMI, there's really no concept of HKCU. Nor do I care about what the context of HKCU would be, because I want to pull back information for all the users, not just one specific user. Are there any questions about that? All right, cool.
Sorry, cool.
Another issue that I've run into some is the fact that there's not like one-to-one parity of all WMI classes across all operating systems. So for example, starting at Windows 8 or 8.1, I forget which one, they introduced a ton, I want to say hundreds of new WMI classes, which are extremely valuable from a security perspective, but kind of out of luck if you don't get those. So basically, like all of the new, or many of the new CDXML-based modules in PowerShell version 3 and above are wrappers for a lot of these new commandlets. So for example, like getNet IP address. In Windows 7, you're not going to get this under the hood. Now, what class am I referring to under the hood? I can look at the implementation of this function here, and its output is this this WMI object. So MSFT net IP address WMI class in the root standard SymV2 namespace. So prior to Windows 8, this didn't exist. So unfortunately, that's just you just kind of have to accept that for what it is. But even moving forward, with the introduction of NanoServer, they actually removed some WMI classes in place for like more modern classes, I guess. For one of the most notable exceptions is, I believe it's the Win32 volume class. is one of the ones that like I relied upon heavily, but just doesn't exist in NanoServer. I believe there's like an equivalent of that class in root standard SymV2 somewhere. Honestly, I forget where that's located though. So it can be annoying in some cases, and you just kind of have to deal with that. And when you're building these tools, these sim-based tools, you kind of have to go with the lowest common denominator, the classes that you know to be present across as many operating systems as possible. Some of the commandlets, or sorry, some of the functions in SimSweep also support ACLs. So for example, get SCS service. Let me pull up some services here. Oh, you know, I would actually have to do this in an elevated context. So I'll skip this demo for now, but the gist of it is there are several WMI classes that support you pulling back ACLs for them. So let's see if I can do this here. Get command, parameter name, include ACL module SimSweep. Okay, so these four functions here support the ability to get security descriptors for the respective object that it pulls back. So in the case of SCS directory listing, you get an ACL for a directory or a file. SCS registry key, you get the ACL for the key. Service, you get an ACL for that. And then you can even get ACLs for WMI namespaces. So I intend to build some automation around ACL auditing for all of these. So far, I've only done it for get CS service in the form of get CS vulnerable service permission. What this does is it enumerates all of the services, pulls back the security descriptors for each one, and then groups what would be considered potentially vulnerable rights for each service. So, for example, if you had the ability to change change the config of a service, if there was an unprivileged user on that system that had that right, well, then that's a vulnerability right there. And it turns out, after I wrote this function, I was testing it on as many operating systems as possible. One of them being my Raspberry Pi running Windows 10 IoT Core. So I ran this, it enumerated all of the services running on Windows 10 IoT Core, it groups all of these services by the group or user. And it turns out that in Windows 10 IoT Core, authenticated users were able to change the config for, I forget the name of the service, but it was a service that ran as system. Any authenticated user could change the config, which means, so that was a privilege escalation vulnerability that I reported. They have since fixed that, but it was just kind of cool that like I was building out this automation around like auditing service ACLs, and I found a legitimate vulnerability in Windows in the process. Okay. Now the way that I typically deal with ACLs is to use this class here, get sim class. So when you pull back these security descriptors, you'll get like a security descriptor object, and then if you want to work with it in a usable fashion, then you need to convert it into a byte array, which you can then pass to a .NET object to build like a security descriptor object around it. And so there's this really WMI helper class that converts the WMI object type for a security descriptor to a byte array, or vice versa, which is really handy. So, you're starting to notice like there's some really cool tricks that you can do in WMI to pull back like this information remotely using nothing but WMI without executing any scripts or executables on the target system. The only thing is, I've already started to describe many of the design considerations and kind of tricks you have to employ to get this information back. So it can definitely have its challenges, but so long as you're competent enough to surpass those challenges, then in the end you're abstracting all this complexity away from the user who just wants to pull back relevant security-related information. So with that, I think that's pretty much all I had to show in SimSweep. Were there any questions that you guys had about SimSweep in particular, or just like sim-based design considerations? I've spent a lot of time on this, so I know a lot of the pain points if you're interested in hearing about those.
Go ahead, dude.
Okay, do you have any thoughts on adding a module for detecting if you're in a VM or not?
Yeah, I mean, that would be relatively simple, I think. I mean, obviously you'd want to ensure that you had coverage across all the VM implementations, Hyper-V, VirtualBox, VMware, all those things. In the end, like, there's all relevant information that you could pull back using WMI. So is it possible? Yes, 100%. You would just have to get creative with how you would go about doing that. So, for example, like, go ahead.
I was going to say the easiest way I found is through the Win32 disk drive class under the caption object.
Yep.
You can test check for QEMU, VMware, VirtualBox, and Hyper-V.
Oh, cool.
Yeah, that's an awesome way to go about doing it, and many of the ways in which you could query that information. Obviously, like, you could get really creative, like, at every implementation, like the VM agent that's running in each guest would probably have like a unique like file-based and registry-based footprint. You could also pull back. I found Win32_BIOS to be pretty interesting in determining if you're in a VM or not.
Yeah.
So yeah, I mean, those are all great ideas. Yeah, I mean, I think that would be some pretty handy functionality. I mean, like, what would your unique use case be? Because, like, I could say there's a really good use case for authors of malware to know if they're running in a virtualized environment or not. But, like, what sort of interest did you have in that?
Wow, you actually found me out. That's what I do. I do malware research.
Oh, nice, perfect.
Yeah.
Could you, I know you went over it, but real quick, the prereqs, this is, you said V3. I'm trying to think what OSs that is by default. That's.
I want to say V3 was like default in Windows 8.1. I could be totally wrong there, but it's available down level to Windows Vista, I believe.
So maybe I'm thinking about this wrong. It's only about your local that needs to be on V3 for these to work?
Yeah,
right?
exactly. So yeah, all you need is PowerShell version 3 or above locally on your analyst system. What's required on the target is just that the WMI service be running, or the WSMan service, or like the PowerShell remoting service be running in order to pull this back.
So I'll ask, I guess, a dumb question, but I know I can't ask you to give away the farm, but can you guys give some kind of examples where this has been beneficial for you as far as forensically, like trying to find something, what you did with it, and how how you implemented it for your own use?
Yeah, sure. So in the end, like SimSweep is just a collection capability. There's no analysis component to it. So the idea is you would collect as much information across the enterprise as possible, aggregate that, and then do, have that be consumed into whatever analysis platform that you wanted, whether it be Splunk, what are some of the other ones out there that are escaping me?
Graylog.
Yeah, like Kibana, Elasticsearch. So like all of the ingestion logic for whatever like sim you wanted to ingest this into would be up to you. SimSweep is just doing the collection. So, for example, one of the first things I would do is run get CS registry auto start across as many hosts as possible, and then start searching for anomalies within that data set. And then, as I already mentioned, I found that legitimate vulnerability in that service ACL using one of the functions earlier.
So even though you didn't really show it, I assume that you pass it minus computer name, or you can pass it an array of computers for it to operate on with your commandlets. Is that correct?
Oh yeah. Sorry, I didn't think to demo that. Yeah. So up front, you would establish a bunch of sim sessions with new dash sim session. Save those off to like an array, and the dash sim session parameter takes one or more of those sim session objects. Yep.
Okay. Awful quiet in here. Anybody else? Well, we're well under time, so I don't know if you're interested in presenting anything else, or if this is it for you for the day, or.
Yeah, I mean, I'm probably gonna have to wrap things up here shortly. Apologies for going short. But yeah, that's about all I got for now.
Okay, so would you entertain the possibility of coming and showing us some of your other functionality that you've done, or some other forensic things that you've done? I'll just work with you on the next time. Whatever that.
Like for a follow-up presentation?
Yeah,
Yeah.
like maybe 3, 4 months, 5 months, something like that.
Yeah, I'm definitely down with that.
But
Do you see a lot of malware these days that uses PowerShell? Because I do.
Oh yeah, all the time. So I'm not doing active malware reversing now, but at my last job on the FireEye Labs Advanced Reverse Engineering team, me being like the PowerShell guy, all the incident responders would just shove all the PowerShell and .NET malware on me. So I definitely saw a lot of it. I mean, unfortunately, a lot of the malware reused a lot of the code that I had written in the past. So like some of the like various shellcode runners that I had written were pretty popular, as well as so yeah, probably the most two popular like pieces of functionality in PowerShell-based malware was the equivalent of like invoke shellcode in PowerSploit and invoke mimikatz.
Thank you for making my job so much more cooler. Yeah, that's it.
Jason Snover just retweeted some code that some bad guys were using to take screenshots. So he said, "That is awesome. Were you involved in that code at all?"
I mean, there is screenshot capturing functionality in PowerSploit. I do recall that tweet. I think whatever actor was using that was doing something else, not related to what was in PowerSploit.
Cool. Okay.
I mean, yeah, like when I was developing all the offensive PowerShell stuff, I mean, I really wanted to help raise awareness of the risk associated with using PowerShell. But ultimately, in the end, like it's not PowerShell that's the risk. It's the fact that you have, malicious actors executing code on your system in the first place. Lee Holmes put it really well in the keynote that he and Jeffrey Snover gave at DerbyCon. He said, "You have a choice in post-exploitation languages, and we'd like to thank you for using PowerShell." Like, once a system's already been popped, like the fact that an actor is executing malicious PowerShell, yes, you should be able to detect that. And there's like fantastic logging mechanisms, especially in PowerShell version 5, to detect that. But really, ultimately, your problem is that you have a code execution problem. You also have a C problem. You have a C# execution problem as well. You need to be able to ideally prevent, but also detect whenever there's any untrusted code, or even trusted code being executed in a malicious context. Ideally, you should be able to detect that and respond accordingly. PowerShell is not the problem.
Implementation, the keys to the kingdom. Cool. What do you think about just enough administration? Is it a good, viable option for that?
I think it's great. So just enough administration should not be confused as like a local preventative mechanism, because it's trivial to bypass that. Like, yes, if I'm quoting Lee Holmes correctly, the last time he spoke about it, apparently you can apply a local GIA session configuration to PowerShell.exe, but it won't apply to, say, the ISE or any other PowerShell host process. So GIA really is designed to constrain what you can do remotely with PowerShell over PowerShell remoting, and it's fantastic for that. I mean, I think it's going to be a while before people start using that heavily, and also there's a lot of caveats involved in that. So you have to be really careful with the GIA configurations that you develop. You don't want to overexpose yourself or introduce unintentional code injection vulnerabilities in your configuration. So I think the area is ripe for research and evangelism. So if any of you want to dig into GIA more and say take like the GIA configurations and apply an attacker's mindset to them and put information out there as to like how to develop secure GIA role capabilities, and I think that's really good information that needs to be put out there. I personally haven't dived too deep into that, though. I'd like to.
Anybody else?
I have one more. What's the most valid, non-hacky, black hat use have you had PowerSploit used for that you know about?
Yeah, I mean, it'd be kind of hard to quantify that. I mean, there's definitely like a wide range of actors, whether they be like criminal or state-sponsored, that they're all starting to use PowerShell pretty frequently now. So I don't know. Yeah, I mean, in my last job, like we had some pretty highly targeted breaches where PowerShell was used pretty heavily. In fact, in 2015, when I spoke in Vegas at DEF CON and Black Hat about some malicious uses of WMI, one of the things that really impressed me was, actually, you've probably heard in the news, DHS just put out their report on Grizzly Steppe, the Russian actor, which they associated with the APT 29 and 28 threat groups. So I talked a little bit about in Vegas about APT 29 tactics, which relied heavily upon WMI and PowerShell. So what I thought was really cool that they were doing was they used WMI as like a covert storage mechanism. Remotely, they created their own custom WMI class and class properties, and they would store their payload in one of the class properties, and then call the Win32 create method to execute a PowerShell runner that would just pull down that property, interpret it as a script block, execute it, take the output. In one of the cases, it was just the output of invoke mimikatz, save the output to the other WMI class property, which allows you to pull that back remotely. So they were using WMI as a pure command and control channel. So for all the benefits that I just showed you of using WMI for pulling back security-related information in a defensive context, the attackers in this case were using WMI, pure WMI, in a really pretty cool offensive context.
That is awesome.
Yep. Now, I mean, so what they were doing, so like they were creating the WMI class and the class properties, so they were using that as their storage mechanism. There's nothing preventing you from, say, using the registry as a very similar storage mechanism. So with the std regprov class that I showed you like the get string value method. Well, there's a set string value method as well. So you can store data in the registry remotely with WMI and also retrieve it remotely with WMI. And you can get code execution remotely with WMI using the static create method in the Win32 process class. Pretty cool stuff.
Pretty amazing. Thank you.
Sure.
I think we're done here.
Yeah. I think everybody's questioned you out, I hope. Maybe not. Well, we certainly do appreciate it, Matt. Thanks so much for your time.
Yeah, my pleasure.
Great stuff, man, as always. And where are you speaking this year?
So the next talk I'm going to be giving with Casey Smith at Blue Hat Israel. We're going to be talking about device guard and various ways to attack it and mitigate against the bypasses that we'll be talking about. And yeah, I guess for the first half of 2017, Casey and I are doing kind of like a device guard world tour, so to speak. We got a gig in Norway, Germany, a few other places. And I'll also be at PowerShell conference in Europe, talking about device guard and how you can use PowerShell to configure it, deploy it, and audit configurations. I'll also be giving a talk on at the PowerShell conference in Europe as well on defensive coding practices. So it's kind of a good tie-in with like the device guard stuff. One of the things that device guard aims to do is, well, it places PowerShell into constrained language mode, which severely hampers your ability to do a lot of useful things that an attacker would want to do. So for example, constrained language mode makes it so that you can't call new objects on, well, there's a very small whitelist of .NET types that you can call new object on. You also can't invoke .NET methods, and you can't call .NET property setters on objects. And you also can't call add type. So the idea is device guard is what I think the execution policy should have been, in that it actually enforces signatures on scripts. So in your device guard code integrity policy, you would have a set of rules that would say, code signing certificates X, Y, and Z are permitted to run either user or kernel mode code. In the case of user mode code, and in the case of PowerShell, if that code is signed by one of the whitelisted certificates, then it will execute in full language mode. If not, or if you're at an interactive prompt, then you're going to be hampered by constrained language mode. And so what constrained language mode aims to do is prevent you from doing like low-level stuff, which if you look at some of the PowerSploit code, by and large, it's like the majority of it does a lot of low-level stuff like using pinvoke and reflection. to call up a lot of Win32 functions. Constrained language mode breaks everything in PowerSploit. So that's definitely a good thing. So in the talk I'll be giving on like defensive coding practices is I'll be talking about ways in which you can prevent code injection vulnerabilities in your PowerShell code. So I mentioned in constrained language mode that you cannot call add type because that would allow you to compile and execute any arbitrary C# payload that you want, including methods that would allow you to call like Win32 functions. So constrained language mode wants to prevent that, but let's say you have legitimate code that is signed with one of the whitelisted certificates. Well, that code is going to be allowed to call add type. And what if add type, the C# that it compiles and ultimately loads into your application domain, what if it takes some string that that can be affected somehow by a user, or in this case an attacker? You might be able, as an attacker, induce add type to inject your own C# code into it and load it and be able to run it. So I'll be talking about ways to prevent that in one of my 2 talks at the PowerShell conference in Europe.
Okay, thanks, Matt. So I guess
That's it, yeah.
Yeah, cool. Thanks so much. We really appreciate it.
All right, yeah, my pleasure. So yeah, hopefully I'll see you guys again in a few months here or so.
Okay, I'll just get with you to see when you're available next time, and now that we got this the live recording down, maybe it's a little bit easier next go around.
Yeah.
Thanks a lot.
All right, yeah, you're welcome. Take care.
All right, ciao for now.